quite clear, no? So here F1, and this frictional force, let it be F2. What is the applied force? 8 Newton. 8 Newton. So here how much it will take the values? 8 Newton, 8 Newton. What is the limiting friction second? 12 Newton. So definitely this 8 Newton cannot overcome. Keep it here. 16 Newton. A very good problem I just picked up. You can see things will be very interesting things are there for different values of F. Let me make 16 Newton. Carefully analyze second situation. Will there be slipping between the blocks M1 and M2? So here what I do is like I'll proceed in the same way. This will be, I think previous problem it was F1. This will be F1. Here I'll assume F2L. I'll assume that no slipping occurs. I'll write down the equation now. So what is the net force acting on system? F minus F2L. Applied force 16, F2L 12 by 2 plus 4. 4 by 6, acceleration 2 by 3 meter per second square. Is I right? Let's calculate the friction force. So who will accelerate the block M2? The friction force only. So here what is the equation? F1 minus F2L equal to M2. F1. What is F2L? 12. What is the value of M2? M1 is, this is 4, this is 2. No? M2 is 2, so this will be 2 by 3. So look at the value of F1. 12 plus 1.3, so 13.3 Newton. Is it less than FL? Any conclusion? I'm really bringing very good situation. When I apply 16 Newton, what will happen to blocks? Blocks, they won't be slipping with the blocks M1, M2, but they'll be slipping with the block M2 and the ground. So what actually happens here? The blocks will move together. No slipping between the blocks. Here slipping occurs. So what is the conclusion I should make it? Slipping occurs here. No slipping here. Sir, how do you can justify this? I got the frictional force. What is the maximum permitted value of frictional force? It should be equal to how much? 16 Newton. But how much I got? 13.3 as static friction acts. When the friction acting between the surface static, then what does it mean? No slipping occurs, and they'll have A relative will be 0. But there'll be slipping between the block M2 and the ground. That's why the limiting friction is acting. Okay, let me give some very high value, some 80 Newton I'll apply it.
So can you repeat, sir? I did not understand.
Sir, here if slipping occurs, there would be kinetic, mu kinetic, no sir.
I assumed I gave only mu value, no? Please make observation. I didn't write mu k.
Yes, sir.
So I just assume no slipping occurs between the blocks M1 and M2. I found out the friction force, so therefore, I got the friction force less than limiting. So what I assumed is right. Finish over. Okay, fine. So now let me take the.
Yeah. Sir, if there is no slipping between the blocks, then the acceleration for M1 should be same as the acceleration of M2, right?
That's what we got, no?
So 16 minus F1 should be M1A.
Check it. Check
Yes,
it, you'll
sir, we
get
are
same
getting
thing.
the same.
Okay, sir, got it.
Next situation, I'll give it. This is M2, this is M1. I'll apply some 80 Newton. Third case, applied force 80 Newton. What we have to do here now? So what were our values of F1L? The same thing. F1 is how much? It was equal to 16 Newton. I'll keep them in hand. And this was equal to 12 Newton. Then here I'll assume as usual, like the F1, like previous problem. And no slipping occurs between the blocks. Nothing wrong. You just carry on the problem. Then the acceleration of system. What is the equation? F minus F2L M1 plus M2. 80 minus F2L. 12 by 4 plus 2. 80 minus 12. 68 by 6. 11.3 something will get it. 6, 11, 11, 2, 3, 3. Let's calculate the frictional force. Any block, either upper or lower block, you take it. So F1 minus F2L equal to M2A. What is the F2L value? 12 Newton. M2 is how much? 2. This is 2 kg block, no? And this is 4 kg block. Into acceleration, let it be 11.3. So what is the value of F1? Will be 12 plus 22.66. This should be equal to 34.66. Is it greater than F1L? At least, okay, now you tell me. Shall we say that no slipping occurs? No, look at the frictional force, how much it is. Greater than F1L, no? So what was the assumption? No slipping occurs, we assumed it. And if the no slipping occurs, the friction acting will be static. Then how much we got the value? But the friction acting is greater than limiting friction. Not possible, no? So then what went wrong? In fact, slipping occurs here. So this is the assumption. No? F1 cannot be greater than F1. So therefore, slipping occurs between blocks. Tell me, like I should come and do correction. The problem is not over. I should come and do the correction. So this is M2, this is M1, this is applied force. Here, what will be the thing? In fact, limiting frictions will act. This will be F1L. Shall I put in simple way? Slipping occurs at all surfaces. And what will be the blocks? Blocks will have different accelerations. Then calculate them. Slipping occurs at all surfaces. So what is the expression for acceleration? F minus F1L by M1. A2 is equal to F1L minus F2L by M2. Okay, see now, this is the final conclusion. Like, so what is the best way of approach for the problem? See, only one block kept on the ground. When you apply force greater than limiting friction, it will shift. Whenever two blocks will come, your thinking should be of this kind. Assume always no slipping first, then check the friction greater than limiting. Slipping occurs less than limiting, then what you assumed is right. Any doubt? I gave almost the very core basic idea of this one. Now we'll take some examples related to the other conditions.
Sir, could you once scroll up, sir?